Hi, welcome to the demonstration and presentation on NJ-SCADA. NJ-SCADA is a Node.js based tool developed by Pramash Technologies which allows you to take a virtual tour of a plant that is connected to ignition SCADA system for and it allows you to monitor the ignition SCADA parameters on the 360-degree images, panoramic images of the plant. So NJ-SCADA supports two configurations. In the first configuration, you can install the the Node.js application, NJ-SCADA application, onto the same physical server as Ignition. So thereby saving one server for you. In the second configuration, you can have Node.js application installed on a separate physical machine connected to the LAN to Ignition. So the advantage of the second configuration is that you don't load the Ignition server with additional computational load, and another advantage is you can have a different configuration of this server. It could be a Linux machine, whereas Ignition could be on Windows machine. So depending on your application, you can choose one of the two configurations. So how does NJ-SCADA works? So NJ-SCADA basically is a standalone Node.js application. So as soon as you start the Node.js, the NJ-SCADA application, it will wait on a timer loop for Ignition to write onto one of its endpoints. So on Ignition, a gateway script has to be started uh, through a memory tag, and as soon as the gateway script is started, it reads the tags.json file, which serves as a database for the NJ-SCADA application. So tags.json file basically has to be generated through a separate offline tool called browse tags. This has been explained in a separate video, but its basic purpose is to generate a JSON file for all the tags that one is interested in that are defined in a tags path file. So you can define all the tags from anywhere in Ignition. It could be from uh, any tag provider or any folder, or even OPC tags can be defined there. So the browse tags script reads this tags path file and creates the tags.json file. Of course, it filters out the invalid tags. We'll explain later. Um, so along with the initial values of at that point of time. So this tags.json file becomes an input to the Node.js NJ-SCADA application. So as soon as the NJ-SCADA receives this tags.json file to the endpoint when uh, this gateway script is started, the NJ-SCADA application initializes its JSON tag structure in the memory, and that becomes the database for the NJ-SCADA application. Uh, so this database is used by the HTML files and the virtual tours and whatever you have on the NJ-SCADA application uh, to drive the displays and whatever HTML files you have. So the clients to NJ-SCADA communicate on by default on port 3000, which can be changed to any other port. So in case of the configuration 1, both the application NJ-SCADA as well as Ignition reside on the same server, but they communicate to the clients on different ports. Now once the initial values are sent, then Ignition sends the tag value pairs of the changed values uh, on exception basis through a tag change event script. which is defined in NJ-SCADA, to another endpoint of NJ-SCADA. So only thing is that only atomic tags are supported in the tags.json file, and at the most you can use arrays, but you cannot use folders or UDTs in the at least in this present version. So basically it's a single array of all the tag paths that are defined in the node tags.json file. Now this version allows only one-way communication from ignition to NJ-SCADA. That is, you cannot write to the ignition parameters ignition tag from NJ-SCADA. But of course, we already have provision to write to the ignition tags from NJ-SCADA, but we have disabled it in this version. And this two-way communication is achieved through a TCP socket. But for the present, for security purposes reasons, we have disabled the writing to the ignition. Only ignition can send the parameters, the tag values to NJ-SCADA. Now also it's possible to run NJ-SCADA in a completely offline mode without any connection to ignition. So whatever static tags.json file has been defined, that becomes an input to the NJ-SCADA, and it will just display the static values of the tags, or you can have the display without any tags. It can be just a virtual tour of the plant, and you can define some context sensitive help on the virtual tours and some videos for training the O&M staff. They can familiarize themselves with how the plant looks like through the virtual, by taking the virtual tour using this offline mode of NJ-SCADA. Now it's also possible to display your own HTML pages. So it's not just the virtual tours, you can have your own HTML pages, making use of a lot of the freeware open source tools like charts and widgets, and you can access the tag values through APIs supported by the NJ-SCADA. So these HTML, your own HTML pages can access the entire tags.json file, which is the database for NJ-SCADA, or a subset of the tags. However, this version we don't have the facility to log the tag values, but in future we'll provide support for the MongoDB or InfluxDB kind of or a simple file-based facility to historize all the tag values. So yeah, I think these are the features, and this is how NJ-SCADA works. So let's have a look at a small demo, and we have configured it for the first configuration, that is both NJ-SCADA and the ignition are on the same local machine. So yeah, as I said, there are these are the scripts, gateway scripts, tag change script. One is the browse tags script. This is the tool that generates the tag.json file from a given tags path file. So it is triggered on one memory tag. So as soon as user sets this to true, this script is triggered and it generates the tags.json file, which is an input to the NJ-SCADA. Then there is a tag change event script, which so you have to list all the tags that are in the tags.json file. So ignition will detect, as soon as it detects any change, it triggers this script, and basically it sends right to one of the endpoints of NJ-SCADA the tag name value pairs. And this is the script which starts the ignition communication between ignition and the NJ-SCADA. So first you have to start the NJ-SCADA application, and it will wait for the script to write to ignition. So these are the scripts. Uh, so let's start the. So this is NJ-SCADA application has to be installed on some folder. So right now we're calling it NJ-SCADA. It could be any folder. You have to change the path name in the configuration file. So we have to start the NJ-SCADA application. So this is in debug mode, so it is given some name. Now it's waiting on a loop for ignition to write to the initial value, send receive the tag.json file. So oops, okay, so this is the tag that will start the communication with NJ-SCADA. But before that, this is an offline script. So basically in the NJ-SCADA folder, we have to write down all the tag paths, the fully qualified uh, tag path of all the tags that you become input to the NJ-SCADA application. So this is basically a database and an array of tags. Now, as mentioned, the browse script doesn't support folders and doesn't support UDT. It supports only the atomic tags. So if you look at the database, we have defined there are some folders, and these are the individual tags, and these are the flags to start to trigger the scripts. So these are all atomic tags, and we have defined one array and one data set, and we have defined one UDT. So motor and motor UDT, these are uh, test UDT is a UDT type, and there are two UDTs defined, motor 1 and motor 2. So if you look at the tag paths file, we have to list down all the tags that you want uh, to serve as input to the tags as a database for the tags, the NJ-SCADA application. So here this is a folder, and this is a data set which is also not supported, and these are the individual elements of the UDTs, one of the UDTs, and this is the UDT itself. So when we run the browse tags script, uh, it will filter out the not supported tags. So if basically I'll just delete the log file so that we can see the errors. Now as soon as I start the browse tags, it will read the tags path file, and in the log file it will write down the not supported. So there is one folder which it has skipped. There is a dataset type variable which is not supported. UDT's instance is not supported, and some of the alarm conditions are not supported. It only supports less than, greater than, and equal to and not equal to conditions. Other conditions like between set points or bad quality, out of range, on condition, bit state, on change. These are the conditions which are defined in ignition, but they are filtered. They are for these conditions are ignored for the NJ-SCADA. So it has generated the tags JSON file. If you look at the folder, yeah, this is the file it has just now created, and tag path new is the filtered list of tags. So it has deleted the folders and the dataset type and the unity type. So this becomes the input. This is basically a database for your tags NJ-SCADA application, and this is the JSON array with the initial values for the from the ignition. When the browse script was executed, those values of uh, these tags are given in this, and that becomes a snapshot. Now after this, uh, the NJ-SCADA application is still waiting for ignition to connect. We just slightly digressed. We went to the browse tag. This should have been executed first. Now we have to click this. So on this, now ignition has sent this to the endpoint of JSON Node.js application, and now it is waiting in a loop of 5 seconds for client to connect. So it has received all the tag.json file as well as the initial values. This is the initial values for all the variables that are defined in the tags.json that it has received. Now if I change some value, it will be reflected here on exception basis. We'll see that later. But now it's waiting for a client to connect on port 3000. So this is the system list. This has to be defined in another file where you define the URLs where your virtual tool is configured. So for example, this system is one of the systems. This is your familiar AR-SCADA application. You can take a virtual tool, you can zoom, and then you can look at it. These are the ignition parameters along with the alarm conditions. So there is a table component, there is a multi-page table component, there is a scale component, there is a bar component, there is a meter component. So and there is an HTML component where you can load your own HTML from your one of your folders, or you can have a video. So you can place these components anywhere in the context sensitive manner so that users can look at some of the O&M, the procedures and uh, operation maintenance manuals, and you can navigate into different sections of the virtual tour, and everywhere you can define one of the components, and this takes you to the floor plan, and with this you go to the home page. And what you see here is basically uh, in every system what are the alarm conditions. For example, in this system we have one alarm here. So if we click here, it will take you to the place where that alarm is appearing. Yeah, this is the place. So these are the virtual tours. But some of the virtual tours need not have any database. It can be just plain virtual tour, for example, this one doesn't have any of the display parameters. It just lets you take a virtual tour, and some of the pages can be static HTML. So this is just an HTML page. For example, this is a documentation for the component, how to configure them. It's explained in a separate video. So this way you can define your virtual tours or static HTML pages or virtual tours without any display parameters, or you can have your own virtual HTML application. For example, we have this MSCADA, we call it mobile SCADA interface. So basically all the components these are defined in the virtual tour, they have been put in the single HTML page. So you can move them, you can change, configure them, uh, you can define the tags which are driving this. So of course this is not part of it's a separate module, it's not part of uh, the virtual tour. So you can define your own HTML page which can make use of the open source components like charts and uh, other widgets. So yeah, now yeah, we have to see how the changes are reflected. Now for example, if I change the value of this tag from 85 to 70 or whatever, so you will see, yeah, so this is your NJ-SCADA application. It has received the change value tag and value pair onto another endpoint of NJ-SCADA, and NJ-SCADA has initialized this uh, value to the new value. That is, if you look at, yeah, I think this is what we changed. Tag 1 we changed. So this refresh cycle is configurable. By default, it is refreshing at 5 seconds uh, from the NJ-SCADA client uh, to the NJ-SCADA server. It is basically an HTML page which is through AJAX calls. It is receiving the tag values that are used in this. It doesn't take doesn't request the entire database. Only whatever parameters are used in an HTML page, a subset of the tag.json file. But of course, it's possible to define your own subset. When you have your own HTML pages, you can define which subsets of the entire tag database this page is going to use. So that way it doesn't burden the communication with additional unnecessary parameters. So yeah, I think that's all about this tool. So, so it's not a module in the traditional sense of Ignition because it doesn't use the SDK. It just uses the scripting functionality and communicates with Ignition with the endpoints. So if you have any questions, please feel free to write to us and request any eval version of this software. Thank you. Thanks a lot for watching. Bye.